Hello and assalamu alaikum viewers. As you all know, my name is Ariadna Naniwala. So today I'm going to take a session on the topic sky. So first of all, assalamu alaikum, Maya, and how are you? What's going on?
Walaikum assalam. I'm doing great. Ready and waiting for our first.
Okay, so let's start our session. And my first question for you is Maya on the topic sky. What is the scientific importance of the sky?
The scientific importance of the sky is that it's basically our giant window into the rest of the universe. Without that layer of gases, we wouldn't have oxygen to breathe, but that same air is what scatters light to give us that blue color during the day. More than that, the sky is where we go to understand time, navigation, and how the rest of the cosmos works. It's our primary source of data for everything from the weather that keeps us alive to the distant stars that tell us where we came from. It's essentially the ultimate laboratory.
Maya, what
You're
a great
welcome.
answer. So my next question is for you. How does Earth's atmosphere influence the apparitions of the sky?
Think of the sky as the atmosphere's visual skin. The atmosphere is the actual physical stuff, all the nitrogen, oxygen, and particles that wrap around the planet. But the sky is the view we get from the ground. When sunlight hits those gases, it bounces and scatters, which is why it looks blue. So the atmosphere is the engine, and the sky is the light show that engine creates.
Maya, you have give some great answers. So my next question is how do clouds form in the atmosphere?
Basically, it all starts with water vapor rising from the ground. As that air rises, it cools down and the vapor clings to tiny particles like salt or dust to form droplets. Once enough of those droplets bunch together, you get a cloud. It's kind of wild to think the fluffy thing you see above you is just billions of tiny water droplets clinging to specks of dust.
Maya, very great answer. I like it. So Maya kindly gives energetic answer. So my next question is what are the major causes of atmospheric pollution?
We, when we talk about pollution, we're really talking about the side effects of a world that's basically always on. The biggest culprit is fossil fuels. Burning coal and oil for power, heating, and cars pumps out CO2 and sulfur dioxide that just hang around and cloud everything up. Then you've got massive industrial plants releasing chemicals that nature just doesn't know how to process. And agriculture's a silent heavy hitter, pumping out methane from livestock and nitrogen from fertilizers. It's essentially a mix of human activity and industrial hunger that we're now seeing the bill for.
Maya, too much great answer. So how does the ozone layer protect life on Earth?
Think of the ozone layer as Earth's own natural sunscreen. It's a thin shield high up in the stratosphere that catches the most dangerous ultraviolet rays from the sun before they ever reach us. Without it, that radiation would be brutal, causing everything from severe sunburns and cataracts to damaging the DNA of plants and tiny ocean creatures. It's essentially the only thing keeping the sun from being too aggressive with us, allowing life to actually thrive on land.
Wow, very the nice answer. So my next question is, how does radar technology help in the weather prediction?
Radar is basically like giving the atmosphere a giant ultrasound. It sends out radio waves that bounce off water droplets, rain, or snow, and then snap back to the radar station. By measuring how long that bounce takes, winds and how strong the signal is, we can map exactly where a storm is, how fast it's moving, and how intense the rain actually is. It's the reason we get those color-coded maps on the news that tell us when to grab an umbrella or head for the basement.
Maya, very
Yeah?
good answer. My next question is going to what causes thunderstorm?
Thunderstorms are basically nature's way of trying to balance out a massive buildup of energy. It usually kicks off when warm, moist air rises quickly into the cooler upper atmosphere. As that water vapor cools and condenses into clouds, it releases a bunch of latent heat, which just fuels the storm even more, pushing the clouds higher and higher. Inside those clouds, tiny ice crystals and water droplets are smashing into each other, creating a massive buildup of static electricity. When that tension finally snaps, you get a bolt of lightning. The thunder is actually the sonic boom from the air heating up and expanding instantly around that lightning bolt. It's essentially a high-energy atmospheric reset.
Maya, very great answer. So my next question for you, how does the atmosphere protect Earth from the harmful radiations?
It's kind of like a layered security system for the planet. First, you've got the magnetosphere, which acts like a giant magnetic bubble, deflecting the solar wind and high-energy particles from the sun. Then, as you move in, the ozone layer in the stratosphere takes care of those nasty ultraviolet rays, which we talked about before. Finally, the troposphere, the layer we actually live in, burns up most meteors and smaller space debris before they even touch the ground. Essentially, the atmosphere is a triple threat that filters, deflects, and burns away everything that would otherwise make Earth a very uninhabitable place.
Maya, very nice answer. So my next question, how does atmospheric pollution affect human activities?
It basically turns our air into a liability. On a human level, it starts with our health, making simple things like taking a deep breath a risk for millions of people. Then it hits our wallets. When smog settles in, it messes with travel, slows down shipping, and drops crop yields because plants literally can't breathe, which means higher prices at the grocery store. Even our cities pay the price as pollution eats away at buildings and monuments over time. It's essentially a tax on every single part of our daily lives.
Maya,
Whose job it
nice answer. So my next question is, how can satellite technology help in the climate change?
It's basically like giving us a global health monitor from space. These things are constantly tracking the stuff from the like glacial melt in the Arctic or the exact moment a forest starts to disappear. They measure things like ocean temperature and sea level rise with pinpoint accuracy, basically turning the entire planet into a live data map. Only we actually see the big picture. Earth is reacting in real time, giving us the hard evidence we need to make actual decisions about the future. Anytime. You're on a roll. What's next?
Abilities do Vermont have towards protecting the atmosphere?
You might have meant humans there, but Vermont is actually a great example of what a committed place looks like. If we're talking about the state, they're kind of the gold standard for smaller places. They've been pushing hard toward 100% renewable energy and protecting their forests, which act like big lungs for the atmosphere. But looking at the bigger picture, as humans, the responsibility is pretty clear. It's about moving away from the fossil fuels we talked about and rethinking how we treat the air as a shared resource. It's a massive group project where everyone has to actually to work. Do you think people are actually stepping up to the plate?
Nice answer. I really appreciate it, Maya. So my next question is for you. How are hurricanes and cyclones formed?
I'm not quite sure I follow. What were you about to ask?
Maya, I don't understand what you say. Kindly repeat your answer.
Of course. I was just saying that protecting the atmosphere is kind of like a massive group project where everyone has to actually show up for it to work. I was wondering if you think people are actually stepping up to the plate.
Maya, I really appreciate your answer. I like your answer. So I'm going to my next question is for you. What is the importance of atmospheric surge?
Hmm. Atmospheric surge. Let me check what they mean by that. And it turns out you're likely thinking of what scientists call a storm surge. This happens when low atmospheric pressure and high winds from things like tropical storms literally push a wall of water toward the coast, which causes some pretty intense flooding. It's basically the ocean and the atmosphere teaming up to make a mess of things on land. How's the live stream going?
Great, Maya. So my next question is, how do meteorologists study at the atmosphere?
Basically turn the air into a giant puzzle that they solve from every angle. They start with weather balloons, which they launch twice a day everywhere on Earth to get a vertical snapshot of pressure and temperature. Then you've got like the eyes in the sky, tracking cloud movements and heat patterns in real time. On the ground, they use radar to scan for precipitation and automated weather stations to catch the minute details of wind and humidity. It's essentially a massive high-tech coordination act to try and predict what the air is going to do next.
What a great answer, Maya. So my next question is for you. What causes the sky to appear blue during daytime?
It's all about a little something called Rayleigh scattering. Sunlight looks white, but it's actually a mix of all the colors of the rainbow. When that light hits the Earth's atmosphere, it bumps into all the gas molecules and small particles in the air. Those molecules are just the right size to scatter the shorter blue light waves all over the place. But actually, I have to jump in here because we're hitting our time limit for this call. You can call me right back if you want to keep the stream going. But for now, that's a wrap. Talk soon.
Okay, Maya, our last energetic answer. Maya, my next question for you is, why does the sky change color during sunrise and sunset?
I'd love to answer that, but we're actually hitting the time limit on this call. The call will end in just a few seconds. If you want to finish the sky session for your viewers, just call me right back and we'll dive into those sunsets. Talk soon.
Viewers, Maya time is short, so I recall Maya and start our session.
Hey, what's up? Sky, huh? It's a wide open topic. You want to go deep into the science of why it's blue, or are we talking more like the
Miles,
the vibes of a midnight sky?
Miles,
Mild,
first,
got it.
my question is for you: why does the sky change color during sunrise and sunset?
Oh, it's basically just a light show caused by the atmosphere. When the sun is low on the horizon, the light has to travel through way more of the Earth's atmosphere to reach you. The blue light gets scattered away, leaving only the longer wavelengths, the reds, oranges, and pinks to make it through. It's like a filter for the sun. Pretty dope when you think about it. You into photography or just a fan of the view?
On the topic sky, so my also
Slow, huh?
Miles, sorry, my next question is for you: how do clouds form in the atmosphere?
Clouds are basically just water vapor playing a game of hide and seek. It starts when warm air rises and cools down. Once it hits a certain temperature, that water vapor condenses into tiny droplets or ice crystals that clump together. When enough of them hang out in one spot, you get a cloud. It's kind of wild that something that looks like a giant cotton ball is actually just a massive collection of microscopic water drops. You like the big dramatic storm clouds or the fluffy ones?
What a great answer, Miles. So my next question for you: what roles
I'm all
does the
ears.
sky play in the weather forecasting? Uh,
It's basically the biggest clue we've got. The sky is like a real-time dashboard for what's coming. Cloud types tell you if you're looking at a light drizzle or a total